Hi there, I'm Hao, and this is just another video of me solving random code problem. So let's begin. Find all duplicates in an array. So given an integer array, nums, of length n, where all integers of nums are in the range of 1 to n, and okay, this is very interesting. So if the length is 8, then we know that all the value will be in the range from 1 to 8, right? 1 is the smallest and 8 is the largest. And each integer appear either once or twice, right? Not 0, not 3, but either once or twice. And return an array of all integer that appears twice. You must write an algorithm that's running of n time using constant extra space. Okay. So let's start by doing it in a easy way that is not constant space. So if we have 4, 3, 2, 7, 8, 3, 2, 3, 1, right? We can use a set, right, to keep track of what we have visited, right? 3, right? 2, right? 7, and then 8, right? And then 2, right? If 2 is appears again, what do we want to do? We want to add 2, right, to the resulting array. Right, same for 3. 3 is already here, right? And then 1. 1 is not here, so we added 2 to the set. So we can easily solve it using the sets, right? But they want us to do in constant extra space. So how can we do this? We need to take advantage of the fact that all of the numbers are in the range of 1 to n, right? Which means that we can use the index to keep track of the number we have visited, right? So if the number is from 1 to n, then we can use index 0 to keep track of number 1, index 1 to keep track of 2, so on and so forth, right? So it would be n minus 1 to get the index, right? And it wouldn't work if we don't have this condition right here. Because if this is like say 18, right? Then we don't have like index 17, like to keep track of uh, the number 18, right? So that is very important that we need to we need to take advantage of this fact right here. Okay, so we can use the index to represent the number and then keep track of the visited number, sure. But how do we keep track of it? Right? So an easy way to do this is we can flip the side of the number as we iterating through the array. So for example, we see 4. Okay, we see 4, right? Which means 4 is visited. So what is the index to represent 4? So we have 1, 2, 3, 4, 5, 6, 7, 8, right? So n is 8, right? The index is 0, 1, 2, 3, 4, 5, 6, and 7, right? So the index to represent 4 is 3, right? This is index, this is a num, right? The index to represent 4 is 3, right? So we can index into here, which is index 3, and flip the side of 7, right, to negative 7, okay? And we can keep going 3. So the index that represents 3 is 2. So we flip the index of 2. We flip the value at index 2. We flip the side of the value at index 2, right? Example here, when we look at the number, we always look at the maximum, right? The absolute value of that, because we have to look at the index of the number. So we always have to look at the absolute value of the number, right? So the absolute of 2 is 2, right? What is the index to represent 2, which is 1, right? So we go ahead and index into index one, and then flip this the sign of the value at index one, and we keep going. Right. So now we are looking at let me change the color here so you know which one is it. Okay. So now we at 7, right? The absolute of -7 is 7, right? What is the index that represents 7? That is index 6, right? Right here, index 6. So which is right here. So we flip the sign of 6 to -3, and we keep going. So now we are at 8. And then again, the index that represent 8, which is 7, right? Right here. So we flip the sign at of the value at 7, which is become -1 here, right? We keep going, right? And remember, we have our result array here, right? Okay. Now we are at 2. So what is the index that represent 2? 1, right? We look at 1. What happened at 1 here? The value is negative, right? Because it is a negative value, we know that we have seen the number before, right? Because we have marked the number to become negative. So we know that we have visited number 2 before, right? So we just go ahead and add 2 in our resulting array. Now we look at 3. The absolute of 3, -3 is 3, right? And the index that represents 3 is 2. So we look at index 2. What happened at index 2? We see that the value at index 2 is negative. What does it mean? It means that we have visited this number before, right? So we add 3 here into our resulting array. We look at -1. The absolute of -1 is 1. So what is the index that represents 1? 0. Right. And now what do? We look at 0, right? It is a positive number, which means we have never visited before. So we just go ahead and flip the sign of the number, right, to -4, and we keep going. Right, and now we are out bound. Right, so we are done, and we can return the response here, 2 and 3, which match what we have in the output. So again, because of this condition, all of the numbers from 1 to n, so we can take advantage of this. We can use the index to represent the number to keep track of the number we have visited. Okay, so that is the algorithm. And then, of course, we need the response array to return as the output. But I guess they don't count it as the space. Okay, we need to use it anyway. So I think what they meant about the constant space is whether or not we are using the set, right? Because we don't use the set, so the space is constant if we don't count the result array. Okay, so let's go ahead and put this up so we can have a duplicate with the result and return it at the end. And we want to through each numbers. So num for each num, right? So if okay, let's do let's do if I think if we look a little bit better. So we have our num, right? And our the number we always be the absolute value, right? So it would be nums at I. Okay. And then we need to find our in. So the index that represents the current number is num -1, right? Okay. And we look at the number at this index, right? And if it is less than 0, what does it mean? Well, it means that we have already visited, so we go ahead and add this number into our duplicate, right? Push num, right? This number right here, right? And this is the index that represents this number. And we look at this index to see the size of the value at this index that represent the number on line 9. If it is negative, then which means this number is already visited. So we add it to our duplicate array, right? If it is not, then what do? We just flip the side. We just mark the number as visited, right? By just flipping the side uh, at of the value at this index. Okay, so that's pretty much it. Let's give it a try. Accept it, submit, and it worked. So thank you for watching.